today I'm going to show you how you go about solving problem 5 as well as 7 on the practice test. So basically for 5 we're supposed to calculate the pOH, the concentration of H, and the concentration of OH for the sample. So we are given that the pH measures to 7.41. So we've got to find our pOH to be able to go from there. So it's very simple. We're going to set it up like this. And we're just going to plug it in. Because we know it equals 14. And then we're going to subtract it from our pH that we were given in this problem, which is 7.41, which will give us a pOH of 6.59. See, that's okay. Here we go. So, for us to go from here, so we can jump from here since we have our pOH and we're going to solve for OH, which is set up like this. OH concentration, which is going to equal 10 negative 6.59. So basically, to find our concentration of our OH, we first have to solve for our pOH, and then we can plug it in to 10 raised to the negative power, which will give us an OH, a concentration of OH of which equals 2.57 multiplied by 10 raised to the negative 7 m. So that's how we get our OH, but to get for our H, it's going to be very similar. I'm going to set it up. So basically, to solve, since we have the pH of our H, it's going to be similar how we solve for our concentration of our OH. We are going to set it up where our concentration of our H equals 10 raised to the negative pH, which will give us 3.39 multiplied by 10 raised to the negative 8 power. Molarity. Pretty much how you go about solving for problem 5. Here's a closer look at problems. So basically, as long as you have your pHs, you're able to solve for this. I can show you later about solving when you don't necessarily have a specific, either you have your pH or concentrations, stuff similar to that. problem number 7 is a little trickier compared to number 5. Give me a sec. I will set it up for you. So basically, in problem 7, we're supposed to calculate the concentration of H and OH when it's in a neutral solution. So basically, you're going to set it up like this. Basically, we all know that it equals H equals OH. Basically, they're multiplied by each other. So, equals, let me get on here, and we have them move it over. Which equals KW. Then we get it to KH raised to the second power. Since basically when they're at neutrals, they're not basically the same. Equals our KW. So basically, we have to, since it's squared, we have to get rid of the square. So in this problem, they give us a KW of 1.10 raised to the negative 13. So this is how it would look once you plug in your data. Basically, this is what it's going to look like, but we're not done yet because we still have the square that we've got to distribute. So, we all know that with a square sign, to get rid of it, you got to take the square root of both sides. So, after we take the square root, we are left with the concentration of H by itself, and our final concentration of 3.2 multiplied by 10 raised to the negative 7th power equals m. So this is basically how you go about solving problem 7, which is not horrible, just a little time consuming, and if you don't have very much space for an exam, this you would have to think about how to properly divvy out your room. Okay, now since I've solved those, I'll show you how you go about solving for, like, if you were given a table of either the pH, the pOH, and how you go about solving for all your all the information you could potentially be posed if given the situation. So, we have problem, let's see, for one of the previous handouts we have, I'll show you how you go about solving for it when you're dealing with acids and stuff, and you're only given one of either you're given the pH, the pOH, or the concentration of H, or the concentration of OH. So for example, if we're only given the pH, and we have to solve for the pOH, the concentration of H, and OH, this is how we're going to do it. Similarly with our problem, we are given a pH of 4.14. So we're going to set it up very similarly, where it's going to be 10 raised to the negative 4.14, which gives us a concentration of H of 7.24 multiplied by 10 raised to the negative 5 power. So, since we have our concentration of, I can wait for that. Then if we were to try to get, so we solved for the concentration of H. Now we can try to solve for, well, we can't yet because I gotta solve this first. So, to get POH, to be able to solve for our concentration of OH, we take our starting pH and subtract it. So basically we take 14 and subtract it by our starting pH, which will give us 9.86, which, so we have our pH. So in a situation, if you were given the pH instead of the H and you were trying to solve for pH, we would set up very similarly. So for example, we would have pH equals 14.00 minus our POH value, which would give us a 4.14, which is less than 7. So our problem is very acidic. So we've solved for the concentration of H, pH, and POH. Let's solve for our concentration of our OH. We set it up very similarly. Which gives us 1.38 raised to the negative 10 polarity. Well, you can also, if you were given, you're trying to find a pH and you're not given either your pH or your OH, you can find your concentration, you can find pH by setting it up very similarly. So we have it pH equals negative log of our H solution, which we figured out to be 7.24 multiplied by 10 raised to the negative 5 molarity, which, gotta put my calculator, 1 moment. Will give you your exact same number as if you were given it to start out with, which is our 4.14 for our pH. And you can solve it the same way if you're given the OH starting out and you're trying to find your concentration of your POH. It's set up very similarly. So, which here's a closer look of how you would write it out and how you go about solving for these. I'll work another problem so you guys kind of get the gist of it, or have more experience seeing what you might encounter and how you go about solving these so you don't get overwhelmed in a situation. Okay. You're given, in this situation, we are given our initial concentration of our OH, and we're going to solve it Okay. So, we can find, since we are given our OH concentration, we can solve our H concentration by setting up our problem like this. This is where you need to make sure you have your KW for your problem, which is going to be 0.0 multiplied by 10 raised to the negative 14 over our OH concentration. In this instance, it is 5.7 multiplied by 10 raised to the negative 5 concentration, which gives us 1.75 multiplied by 10 raised to the negative 10. Make sure you add your concentration. So, since we found our H, we can solve for our pH, which is set up like this, like the beginning problem, negative log, and then we just plug in our H here. Which gives us a pH of 9.76, which is greater than 7. So this is a very basic problem. So we can find, since we have our pH, we can go about finding our POH, setting up very similarly. We're going to subtract 14 by our pH, which is going to give us 4.24. And then, just so you guys are given a example of how you solve about finding the concentration of OH without having it starting out, we're going to set it up as our concentration equals 10 raised to the negative 4.24. So basically, to find OH, we were able to find it when we set it equal to 10 raised to the negative POH. Same can go with if you need to find H, depending on what you start with, which gives us our starting number, which is 5.75 multiplied by 10 raised to the negative 5. And make sure you add your M. And this is a good spot to end this video. If you have any more questions, leave them down below, and have a good day.